Hello everyone, and welcome to AWS Solutions Architect, a short course presented by IT Masters on behalf of Charles Sturt University. My name is Guy Coward, and I'll be your MC for the duration of this course. Your mentor is Scott Farrell, who I will introduce shortly. Before we begin though, some housekeeping. All webinars for this course will be held at 8 p.m. Australian Eastern Standard Time, with recordings made for those of you who cannot attend. If you can make it, we hope you'll attend as many of the webinars live as you can and help contribute to a collaborative learning environment. As you can see and hear, we use Zoom for our webinars. We encourage the asking of questions and the use of chat during the webinar, and there are two ways to do so with Zoom. We ask that you direct all course content related questions to the Q&A section, and that you send all administration type questions to the support team in chat, sort of like, when's this going to happen? How is this course going to work? You can chat with panelists only, or the people from IT Masters and Charles Sturt University, or to your fellow students as well. And you can make that choice by toggling through the drop-down box once you have opened the chat log. There are usually some attendees present who are very experienced and embedded in the industry already, and they will very often have great insights to augment Scott's content and just have some corroborating stories as well. We might have Q&A sessions periodically through the course, and we'll certainly have one at the end of every webinar. And if there's a particularly relevant question during Scott's presentation, I'll interrupt and ask that. For those of you who've never taken part in a short course with us, and that's about 45% of you this time, IT Masters is a training organisation that exists in partnership with Charles Sturt University, or CSU. We work with them to create and deliver a number of their master's courses online. And we also market these courses on their behalf and think that the best way to do so is to give some of it away free. If we do a good enough job, students will be encouraged to enroll in the full masters if it suits them. But with all that said, I really hope this course stands alone in its own right and is its own reward. We want you to learn some useful information over the next few weeks, hopefully have a bit of fun and make connections with your fellow students while you're doing it. Chantel and Barry are around tonight in an administrative and technical support role for IT Masters, and Angus is back for some vital meme work in the chat. And they're all responsible for the learn.itmasters.edu.au website, which is where you'll find the other materials needed for this course. Readings, slides, we'll post them soon, discussion forums, plus the weekly quizzes and labs. I ask that you please hold your course detail questions until the end of the webinar. We'll get to all of that at the end, and we'll have a nice long Q&A session tonight. Just gets the first week, we'll get all of that out of the way. In any case, if you have any questions after the webinar, sort of over the next few weeks, please feel free to contact us using the details on the course page at learn.itmasters. A link for which we'll soon paste in the chat. Next week, a representative from CSU, Jason Howarth, will be in to talk a bit about the institution and give you an idea of what studying with CSU is all about, as well as how these short courses can help you in completing a postgraduate course. So if you have any questions about CSU or the courses in general, hold them over to next week and Jason will likely answer them. But now it's time for your mentor. Scott Farrell has been lecturing at CSU for a little while now, and he also holds 3 AWS certifications. He has extensive industry experience as both an employee of big firms and experience running his own consultancy. It's my first time working with Scott, so I'm very excited. And could you please give a warm welcome to Scott?
We've really covered that, so I'll just skip on. I just want to talk about the subject style. So we're very focused around AWS and a very hands-on focus. So we'll be talking about the certifications and so forth, and I'll be generally covering content that's in the certifications. As Guy said, I've done 3 certifications, so I know what the questions are like and the sorts of questions they ask. Class time will also cover some theory and extension topics that are what I would consider postgraduate information, which is above and beyond the basic certifications. I'm sort of expecting people to do some pre-reading before class from the textbook chapters that's allocated. The lecture is not going to be a summary of the textbook, so the textbook is going to be assumed before you come to class. And we'll look at up-and-coming deliverables. We'll go through some extension topics in the slides, and then at the end, we'll have some time for Q&A, as Guy mentioned. So the materials you should be looking at. So your main point of focus is learn.itmasters.edu.au, and that'll point you to the weekly learning materials, the quizzes, the forums, and other resources that you might need. So make sure that's the, your first point of call when you want to find out what's going on. The textbook's listed in the materials, and it's accessible via Kindle. Not everyone's got a Kindle, but you can also view it in a web browser. So you can't actually download it. It's not a PDF or anything, but you can view it on Amazon's cloud reader. The quizzes and exam focus is on the textbook and the slides. And as you go through tonight, there'll be some hints towards the quiz questions as we go along. There's some labs that we'll have every week, so that that's to get some hands-on, to do some bits and pieces with AWS, and the labs will lead to questions, and it'll help populate the forums, and people will be asking things in the forums about the labs. I'm not going to specifically go over content that's in the labs. That's for you to learn in the labs, and I'm trying to do more in the lectures above and beyond the labs. The labs are organised by AWS. You'll need your own AWS free account. So most of you know about those free accounts already. You get so many resources from AWS for free. You've still got to put your credit card in up front in case you go and do something silly. They'll charge you. But if you stick to the labs, you won't get any charges from the labs. And just a couple of tips: when you finish doing your labs, make sure you try to turn off some things when you're finished. It's good practice anyway. So turn off your EC2 instances and delete your volumes, resign your elastic IPs, kill off any RDS instances. If you're sticking to the free tier and you've launched a free tier EC2 instance, for example, you can run it forever and leave it running. But if you've launched it the wrong way and it's slightly outside the free guidelines, you won't know directly straight away. And if you leave it running for a long time, you might get some charges. So it's just a good idea to clean everything up. And all the labs are based around resources from the free tier. So you should be okay with that. I think hands-on is a very important way of learning IT subjects in general. So do try to get as many of the labs done as you can. I'm not here to teach Windows and Linux because we're really talking about cloud computing. So if you've got questions about Windows in particular, how does this license work? How does that one work? How do I install this piece of Windows software? It's really not the place to be asking that. The certifications does cover questions from Windows and from Linux. So if you've only ever used Windows, it's important to go do the Linux lab and vice versa. Some of the times you might only want to do the lab if you're doing it for work and you're in a corporate and you only use Windows. Well, there's probably no need to go and learn Linux either. So you can just stick to the Windows lab if you like. Okay, let's have a bit about chat about what EC2 is. So the textbook definition is a service that provides a secure, resizable compute capacity. It's designed to make web-scale cloud computing easier for developers. An alternate definition, EC2 is a service that allows people to rent virtual machines that run in Amazon's data centers. So I guess a lot of people are aware of virtual machines in a Windows environment or a VMware environment. And so we're really just running them in the cloud using Amazon's virtual machines rather than your own ones on your corporate premise or on your own PC. And another industry term is a VPS, a virtual private server. And so that's the same thing as a virtual machine. Amazon calls them instances. Some people call them VPS. Some people call them virtual machines. They're really all the same thing. So they're very much interchangeable terminology. So a lot of people use the word cloud, and it's a very nebulous term, and a lot of people use it for a lot of different things. So when we talk about cloud, we're talking about on-demand access to a shared pool of computing resources. So AWS has got a huge amount of machines sitting there ready for you to use, and you can start up. We're looking at EC2 tonight, so you can start up as many or as few EC2 instances as you want, and they're launched straight away, and you're up and running. And so when AWS talk about the cloud, it's any of their resources that you pay for as you go is part of their cloud. So that might be storage, it might be internet access, it might be security. And tonight in particular, we're looking at their instances or virtual machines. So any of the things you pay for by as you go is what we're really calling cloud. A lot of people think why you use AWS is to save money. And a lot of people think that's sort of front of mind, we're using AWS to save money. But I'll let you know now that you'll get yourself into a lot of trouble if you answer questions based on saving money. So even in the quizzes, or you're doing your certification, or your boss asks you a question, if you answer the cheapest answer to save money, you're probably going to give the wrong advice and get the answer wrong. So try not to make your designs the cheapest that you can. So what we're trying to do is make solutions that are right-sized and technology fit. So the idea is we've got the problem, we're talking to the customer, and let's get the right instance or the right piece of cloud that fits that, not the cheapest one, but one that fits best. And here's my little analogy. If you're in a sprint race, don't buy gum boots because they're on special. Not only will you get the answer wrong, you look silly at the start line. So don't be the person that's recommending gum boots for Amazon instances. Did I just chop off there, did I?
No, we heard your audio, I think.
Okay.
Your video seems to have paused in a very expansive mode.
Yeah, I had my hands up there. Okay, there. Stopped and started it. I just looked and saw that it was changed there, yeah. Okay. So EC2 is a virtual machine. So AWS says EC2 instances are ephemeral, and they use this word a lot, and it's something it's not a word I came across very often before Amazon started using it. And what they just mean by that is it's disposable. So when you start up a virtual machine, Amazon consider it disposable. And that when you're designing, you should keep that in mind, that Amazon consider it disposable. So what that means is they can turn it off at any time. It might break. They don't guarantee that if you start a EC2 instance, that'll stay running forever. And there's a lot of instances where they do get turned off. They do break, but your design's supposed to take care of that. I'll give you one example. If you start up an instance on an older technology, so you can start up technologies that go back 5, 6, 7 years on an older sort of technology instance at Amazon. And if you try to run it for 2 or 3 years, eventually they'll say, we're going to turn off your instance. I'll give you 30 days notice. We're going to turn off your instance because we're actually getting rid of that physical server that you're on. So that happens now and again. So the idea is to design around the fact that that it's ephemeral. And so you might be replacing servers on-premise. So on-premise means inside your own corporate. You might be replacing other VPS servers from other providers or co-location servers. So these are the common usage scenarios for using EC2. Instance types. This is, I'm going to go and bring this page up quickly. And this is something that there's a lot of test questions around, and you start to need to learn about these instance types. It's fairly important. So one of the things happening when you're designing your cloud for your client or your corporate or yourself, you need to know what instance types you might be wanting to use. General purpose instance types is the most common that you want to use. Compute optimized are very common as well. I'll go through a bit more of these in detail in a sec. And there's different sorts of generations of them. The number is how old they are. So the M4s are older than the M5s. The M5s are the latest technology. Same, so the T2s are older and the T3s are newer. The A1 is a totally new thing they just invented a couple of months back. And I'll talk about that in a minute as well. So if you've got a choice, you should start a C5 and not a C4 because they're newer and they're faster and they're better. And the memory optimized ones, they start with an R, and these are newer, very much newer. So check out this one, high memory. You can run 12 terabytes of RAM in a virtual machine, not 12 gigabytes. 12 gigs of RAM is what a sort of a PC would have. This is 12 terabytes. It'd be 1,000 times more memory than a PC might have. So that's just crazy. Accelerated computing. These got GPUs in them. A GPU is a graphics card. So it's for doing video processing, or they've got these really cool things called tensor cores, which I won't talk too much about, but that's for doing artificial intelligence and machine learning. So a GPU is about 50 times faster than a CPU at doing graphics loads. And a TPU or a tensor core is about 1,000 times faster than a CPU at doing machine learning. So if you're doing one of these specific jobs, you should be aiming at these sorts of instances. Storage optimized instances where you've got more storage on the virtual machine. I won't go back down to there much further. So you need to be aware of all the different instance types, and I'll just go through some of the notes I've got about instance types. So the common ones are the general, the compute, and the memory R for RAM. So they're the more common ones that you'll use. So you should default to using the general purpose ones, unless you've got a reason to go to the C or the R. They're exactly the same. They've just got different, the different shape. I call them different shapes, more or less memory and CPU. I'll show you what I mean by that. So let's get back to the general compute ones. So the M5 is what you should default pretty much all workloads to. And the M5 large, for example, has got 2 CPUs and 8 gigs of memory. If you have a quick look at the C5, they start at 2 CPUs and 4 gigs of memory. So the shape is a bit different. It's got the same CPUs, but less memory. So it's more CPU dense. If you look at the memory optimized ones, it's 2 CPUs with 16 gigs of memory. So it's the same amount of CPU, but with more RAM. So depending on what your workload is, you might want more memory, less memory, more CPUs. So that's why I call them different shapes. It just depends what shape you want there. There's storage instances that are less common to be used. I don't know many people use them at all. And here's my big warning of T instances. Pretty much, I don't want anybody to use T instances. if you tick off T instances for any question in an exam, you'll get it wrong. A T instance is burstable. So what happens is you've got credits that most people don't understand, and you've only really got access to run that instance for about 15 to 20% of its life cycle. If you run it for more than 20% of its time, Amazon just pretty much turn it off on you for, like, if you use it for 20 minutes continuous, they'll turn it off for 40 minutes, which doesn't seem very useful to most people. So what happens is you start running a website on it, and it runs good for a day or two, and then all of a sudden it's off for an hour, and everyone's trying to work out why it's broken. It's because you used a T instance. So try not to use T instances. There's a lot of newer instance types like A1, T3, and M5A, T3A, M5A. These are different CPU types, and again, unless you've got a really good reason, I wouldn't answer those answers or recommend them to customers just yet. So the A stands for AMD, and the A1 here, the A at the end stands for AMD, and the A1 is a whole new CPU that Amazon's invented themselves, and it's only available on Amazon. So then these are also sort of for corner cases that people might want. And we had a quick chat about the GPU and TPU instances that are very cool, but you don't really need them very often. Just checking the time, we're not going too badly.
Just a quick question, Scott. We've had a couple of people asking what's a T instance good for then?
Okay, so a T instance is good for something that you might use occasionally. Now, development servers is a good example. If you're only going to use it for a couple of hours a day and it's off for 16 hours a day, your credits mount up when you're not using it, and then you can use them during the day. But again, if someone goes and slams it for a whole bunch, it'll outage. So sometimes test servers are good for T instances. And there's corner cases where you can use them in fleets that you'll have a burst of activity. You know you're going to have a burst of activity and then none for a few hours and then a burst and then none for a few hours. So if you use them smartly, they are good. But almost always it's the wrong answer. And I say this early in the course because when we do exams and assignments, so many students answer T because they're less than half the price of the equivalent G instance. And everyone thinks, well, that's just cheap, I'll use that one. But anyway, it's almost always wrong. Okay, instance purchasing. So there's three main ways. I'll let you go read that page later. There's three main ways that you can purchase instances. The most common by far is on-demand instances. So you pay by the second, and this is the standard. So if you launch an instance and you don't say what you want, you get an on-demand instance. Reserved instances are very common with corporates, where you have to commit for 1 year or 3 years, and you either pay completely upfront, partially upfront, or none. And the idea of reserved instances is to reduce your price. So the on-demand instance is the highest price that you can pay at AWS, and you pay by the second. But if you want to save a few dollars, you commit to AWS, yeah, I'm going to keep this running for 3 years, and you get a discount. And your commitment is to run so many instances. It's not to commit to a particular instance. You might want to commit to 3 extra large instances, and you can turn them on or off or allocate them to different ones as you go. So it's just a money-saving thing. They run the same. Less common are spot instances. And again, everyone thinks this is pretty cool, but they're hard to use. They're cheaper than the on-demand instances, and there's sort of a bidding system where you bid to use them, and they're cheaper. They're roughly, say, half the price of the on-demand instances, but they're hard to use. And there's less use cases to use them than you think. So they're a way to save money. And remember when I said, if you're answering questions to save money, you're probably getting the answer wrong, and you're probably giving your client the wrong answer. So you put in a bid price, if your bid's accepted, your instance runs. If the market goes up and then your bid price is not enough, AWS turn off your spot instance. So if you've got a website or it's running a database and it turns off because your bid instance goes down, you don't really want your website turning off and then turning back on and turning back off when the bids change. So it's not the best thing. But if you want to, where they do get used is you might have a job to run 1,000 reports, and you might want to do it with spot instances to say, well, I'll take up to 1,000, instead of running one report at a time, which will take 1,000 hours maybe, you can run all the reports at once using spot instances. So start me 1,000 instances AWS, and I want to pay no more than $1 an hour. And if they can only start 500 for you at that price, well, they'll start 500 and then you'll just take 2 hours to do it. So there are cases that you will want to use spot instances, but it's rare. And even more rare are scheduled instances, dedicated hosts, dedicated instances, and capacity reservations. So that's the 1, 2, 3, 4, 5, 6, 7 ways you can buy instances at AWS. They're more rare, so I'm not going to go into a lot of detail. You can sort of guess what dedicated's about. It's dedicated to the one customer. Scheduled instances are the same thing as reserved, but less than 24 hours a day. So you might commit, I'm going to run this instance for 8 hours a day for the next 3 years. So that's, some people use that sort of thing. All right, I'm going to do a few little demos now. You got any questions there coming up, Guy? Or?
Yeah, we got a few. Might go to them now, may as well. A couple of good ones from Hayden. About the certification itself, does the AWS Solution Architecture certification map to a particular enterprise architecture?
To particular enterprise architecture? Not really. So enterprise architecture, I guess you're thinking about Windows or Linux or VMware. I'm trying to think about what you might be asking there. So, for example, if you do have on-premise VMware, AWS have a lot of things that connect straight to VMware, and you can move workloads straight from VMware to AWS.
Hayden's posted in thinking about TOGAF, Zachman, Sabsa.
I think I'd have to look at that question separately.
All right, maybe we'll hold that one over to the end.
Yep.
And then there's a couple more questions. What does newer and faster actually mean better? It's about requiring an understanding of business requirements. That's probably more of a comment. And then we've got, how easy is it to reshape your instances? How can you better understand the shape of instances?
Good question. That's a good question. So we talked about your instance types, and I talked about them being a shape, the G, C's, and R's. And even if you start up a T wrongly and you decide you should be on a G, so in AWS, it's a matter of you have to stop the instance, and you have to create a new instance, but your data is saved on a volume, which is separate. So you just use the same volume and you point at a different instance, and away you go. And then you start this. So in a Windows terminology, you'll have a C drive. So it's the same C drive, but you boot up with a different instance size or shape, and away you go. So you do have to bring it down, swap the volume to a different instance and start it again. But a couple of minutes and pretty straightforward.
Yeah, absolutely. Might move on just to get into the demonstrations.
Great.
We'll have another Q&A in another sort of 10 slides or so.
Great. So I'm going to have a quick look at some reboot on failure type things. I don't know how many of you have got into the AWS console, but this is a list of my running instances over in US East 1, North Virginia. And you can see I've got one here stopped and one here running. And one of the things to learn about it is you've got a thing called status checks. And this is something Amazon does for you by default. And it says both of my status checks, 2 or 2, are running okay. And the status checks, one's a system status check and one's an instance status check. They do slightly different things. I'll let you read what they do later. But one of the issues at Amazon, when you use AWS, everyone thinks, oh, I've got an instance up there. AWS will keep it running for me and it'll be great. But there's very clear division of duties with Amazon, and it's their job to keep infrastructure running, but it's your job to keep your applications and your operating system running. And so Amazon might change this to 0 of 2 and a red cross if your application's not running, but it's your problem to then get the support call going, and you could reboot your instance if it's broken. But check out this. We'll go into CloudWatch monitoring. We'll add edit alarms. I've already got one here that if the CPU utilization stays too high to reboot it, but we're going to create another one. And we're going to say, take the action, reboot the instance if any of our status checks fail for at least 5 failures for 5 minutes. So if Amazon, their instance checks, these status checks that we were talking about before, if these start to fail for a period of 5 times for 5 minutes, so for 25 minutes. So if AWS thinks it's broken, we're going to take a step of rebooting the instance. There's other steps you can take. You can email people, you can send them SMSs. There's all different things you can do at the top here. But for now, if Amazon thinks it's down, we'll reboot it. And then you just hit create alarm. Alarm created successfully. So that's pretty cool. And when you're creating them, I'll just go click. There's lots of different things you can pick off. CPU utilization, disk reads, network. So you can do things like if there's not enough network activity, reboot. If it hasn't read to disk in the last half an hour, reboot because it's probably broken. So you can work out things like that for yourself. Especially if you've got a troublesome application or an older application that needs a bit of rebooting now and again. You can see this does a little bit of work sometimes. See, there you go. That'll be okay for a T instance maybe. It only does a little bit of work sometimes. But it's on the M3. And as you'll know, the M's are the general purpose ones. Okay, we'll just go back to slides now. I think I've got the other demo to do, a demo from command line. So most people see the AWS console and use the web console and think that's how AWS is managed, launching instances, changing firewalls and everything through the console. But everything you can do through the console, you can do programmatically. You can do through a command line. So I'm just going to give you a few examples of through the command line. The first little job I've got is AWS EC2 describe instances, which just means show me what running instances I have. So I'll just run that for you. And you get back a sort of ugly JSON file that's sort of human readable. It tells you about the instance. Here's its IP address, for example. It's Linux, so that's its first hard disk. Type of C1 medium. Tells you a bunch of different stuff. So, but because it's programmable, we can query it and we can look through that JSON and we can do something like get IP. So we can go through the list of instances and get their IP addresses out, for example. I'll show you that little bit of code. I've got a slide for that as well. So that gets the instances and then uses a program called JQ, which reads JSON to get out look in the reservation, look in the instances and get out the IP addresses. There's other, so this is the command line API. There's other web-based APIs. And anything you can do through the console, you can do through programmatically. So you could program it to launch instances. You could program it to stop instances. You could program it to do just about anything. So the programmability is just as important as the instantly being able to launch things in Amazon. So yeah, here's the command lines that I used. AWS EC2 describe instances. And then I ran the same list program and then pulled out the reservation instances and the private IP addresses. Now, why coding infrastructure matters? So that's what I was talking about before, programmatic access to EC2. Now, I'll just give you a little use case here. Suppose you need to process videos. Let's say we're going to add watermarks, and your client wants to add watermarks for 100 hours of video. And each hour of video takes 4 hours with 4 CPU cores. So how long is that going to take? 100 hours times 4. It's going to take 400 hours to process to get the watermarks on those videos, isn't it? 4 times 100. That's pretty straightforward. But I think it'll take about 5 minutes. So instead of launching one instance that's going to take 400 hours, no one wants to wait for that, you could launch 100 instances, and each of them does 1 hour of video. But what if you launched instances with more than 4 CPU cores? You launched instances with 16, 32. I think you can launch 72 CPU core instances. So that'd be a lot quicker. And remember before I said you can launch GPU instances as well. So if you're processing video, that's what the GPUs are awesome at. You could be done even quicker. So if you're trying to do this by hand and you tried to launch 100 instances with the web console, clicking with your finger, you're just not going to get there. So you need a program that talks to EC2 that says, here you go, launch me 100 instances of 16 cores, and each one, here's the job that they've got to do. And when they're finished, they quit. And you just get charged for the instance minutes that you were running for. So do people see how coding of it is very important? You can turn a 400-hour job into a 5-minute job. This is the sort of thing you can't do without cloud. You can't do this on premise. You wouldn't be able to launch 100 instances on premise. You just wouldn't have enough compute power. Okay. EC2 as it's meant to be used. So you're meant to set up EC2 with no single point of failure. You're meant to scale horizontally, not vertically. So in the last job, scaling vertically is talking about making larger instances. So if your website's going slow, for example, and your boss says, oh, let's make the website go faster, and it's already got 4 cores, you might think, oh, let's just stop the instance and start it again with 8 cores. Remember we had that question before, how to change it, change the shape? So you just have to stop it and start it again with 8 cores. That's vertical scaling. But the problem with that is then your boss comes and says, it's going slow again. We need to go a lot faster. So you go to 32 cores, and eventually the instances, you run out of cores and it doesn't work. So scaling horizontally is talking about launching more instances, not less instances. So it's like this last slide. So horizontal scaling is starting off 100 small jobs at the one time, instead of trying to start one huge job with a huge amount of cores. So EC2 is meant to scale horizontally. And it's meant to be used in an elastic manner. So what that means is if we're scaling horizontally, say from 1 to 100, we should scale in and out based on our workload. So overnight, your application might only need 3 EC2 instances for overnight processing. But as soon as 9 o'clock comes and all your staff comes into the office, everyone clicks on, show me what happened last night, show me the report. And then you've got 200 staff members clicking on that. the amount of capacity you might need might spike up at 9 o'clock. So you might need to start 50 instances. So that's to meet that. But by 10 or 10:30, that might have dropped down to needing 20 instances. That's what it means by elastic. Start the right amount of instances that you need. And that's when you're using the cloud properly. You're scaling horizontally and you're being elastic, using the right amount of instances. And that's the real answer to the first person's question that asks, how do you reshape it? Well, you're not really supposed to. You're supposed to start with a reasonable instance size and then scale horizontally and then elastically to meet the demand. That is what you're supposed to be aiming at. And so if one virtual machine fails, if one of the instances fails and you've got 20 running, it probably doesn't matter. If you've got one running, it's huge, that's 72 core, and it fails or the operating system balks or something, then your whole application breaks. Remember I said you need to treat the virtual machines as disposable and designed for failure? That's an important part of what AWS is out. This is a little technical note about Netflix has got a thing called a chaos monkey, which is pretty cool. So they've got a little application that goes in and specifically breaks a bit of AWS and then sees how their whole application can still continue, even with something broken. So they practice breaking their application, probably in a test environment, not in production. And the idea is to treat data centers, Amazon call them availability zones, as disposable as well. So the idea there is if the whole Sydney one data center goes down, that doesn't matter because you've got some assets in the Melbourne data center ready to take over. And that's EC2 being used to its best capability. This is where I want you to chuck up the poll, Guy. So why do CEOs and CEOs decide to use cloud and AWS? I just want people to think about why. Why do people go to cloud and AWS? What's the thinking behind it?
And for those who are watching the recording, we sometimes have problems displaying it in the live recording. We've got options because other companies do, because AWS computers are faster for applications that need less security because the cloud is less safe, to reduce IT staff costs and to save money. And those last two, to reduce IT staff costs and to save money, seem to be taking up a fair chunk of the votes. We've had 40% voting so far.
But even the first two have got a good vote.
Yeah. 850 attendees, by the way, still.
So I'll say there's no real wrong answer to this. So I'm not going to come and say what's the right answer because this is sort of an opinion sort of thing. And I've got my ideas on the next slide. So,
all right, beauty. Well, we've had the poll for a minute, so
yeah, thanks.
70% voted. I'll end that and share that screen now, and we've sort of got mostly to reduce IT staff costs, 40%, or 38% to be accurate. To save money, 27%, because AWS computers are faster, 23%, because other companies do, 11%, and only 1% because applications need less security.
Okay, so this is why I think AWS and the cloud gets used. AWS has got a name around the place about not being cheap. So that's the first thing I'll say to you is going straight to AWS doesn't save you much money in the first instance. Because often you've already got on-premise IT assets that you've already paid for, they're already bought, and they've probably got some life left in them, and now you're going to go and buy the same thing again at AWS. So there's a lot of reasons why it's not cheaper. Here's the ideas of why I think it really does get used. It's best of breed and it's best practice. So remember how I said using Amazon AWS to its best, the way it's meant to be used. So no single point of failure, scale horizontally, elastically, treat machines as disposable. These are all the things you can't do in your own office. You can't scale horizontally easily. The elasticity is really because you have to buy computers to run them in your own office, to run them in your own data center, how can you be elastic? Because you have to purchase them. That doesn't really work. And as much as people try to design no single point of failure, it is really quickly the IT staff, or you might have all your assets in one data center and maybe a backup on a second data center, but there's so many points of failure usually. So you're just buying into best of breed and best practice. Separation of duties, we'll study this more during the course, but there's things that the IT staff aren't good at managing, like physical security, environment threats, and power. So we've outsourced that to Amazon, and you're going to get best of breed and best practice for all that, and Amazon's going to run it for you. And the fact that they document all their processes, they're all knowable and auditable. Normally, when you have your own IT assets in a data center, none of that's knowable or auditable about who manages the power, what physical access have you got. Most of it's just trusted based on the IT staff. So the separation of duties is Amazon does some, and then it's quite clear what ones you're responsible for. So you're responsible to manage application security, for example, and you're to set the firewall policies, for example. So the separation is a really big part of why, especially CIOs like AWS. Capital cost versus expense is a big one. So I'll say you're not trying to save money, but capital cost is where you have to buy servers up front in your own data center, and you sort of have to buy it for 3 years, and you have to sort of guess the capacity, and you have to buy big ones and then you sort of have to grow into them, and you have to pay for them up front. You have to pay for them now, ready for 3 years. So, but when you go to AWS, you get a monthly bill for what you've used. So that's an expense item as opposed to capital cost. So that's an accounting argument. And it's a variable cost to match required resources. So in your own IT environment, like I said, you have to buy it up front. And what are you matching? You're matching a guesstimate of what you need for the next couple of years, as opposed to the variable cost of what you actually used. So when you get billed by AWS, it's actually what you used. You didn't get paid for things that you didn't use. So that's pretty cool. And it changes the philosophy of you're investing in applications. So we want to run this new application for this business unit. And this is the AWS cost that's going to drag with that new application. So we're investing in the application, not in buying computer hardware. So it becomes a better discussion in the corporate environment about this is how much this application is going to cost, as opposed to some IT bloke saying we need to buy some more servers. And we're going to match costs to business owners and to outcomes. Because it's variable, it's based on the application, we can funnel it and show exactly how much each business unit, each business owner, and each application is costing us, because we can track exactly what AWS costs go into exactly which application. And AWS actually help you do all that. And so you get reports out by business department, by business owner, and by application about who used what costs. And speed to market's another thing. So you can have an application and spin it up in test or development and spin up any amount of resources, instantly, and you don't have to buy them and configure them and deploy software on them. It's in minutes and not days and weeks that you might have to do it in your own office. So that's why I think the move to AWS and cloud resources is really about these sorts of things. Okay, so I've just got a few points more about failures and managing failures. So I guess everyone knows this is Sydney. We had some really big storms back, it's now 2016, it's now 3 years ago, say. And there was a massive outage in the Sydney AWS data center. They got power outages and they got flooding at the same time. And it just, 16 hours or something, bang, AWS Sydney got knocked out. And things happened like spot instance prices went 10 times the price. And depends on, and then they slowly come back after 16 hours. I don't think they lost much data, but instances turned on without their databases. And then, you know, IT staff had to go in and reboot the instance because the database wasn't running at the right time. So there's a lot of cleanup for people to do. But the idea is if you had half your application split and running in Melbourne in a different, what Amazon call an AZ, availability zone, you wouldn't have had any outage at all. So Amazon don't guarantee they're going to keep stuff running for you forever. And it's up to you to design your application to have failover between availability zones or regions. You can fail over to the US if you want as well. Average latency between availability zones is 2 milliseconds. I think it's better than that these days as well. So Amazon's networks are pretty quick. And if you're replicating a database between availability zones, it's pretty quick as well. They charge you less to replicate between availability zones. It doesn't go over the internet, so it's fairly cheap, these sorts of replications and things as well. It's quite practical. And that's what they sort of push you to design, these sorts of multi-AZ applications. This is how the AZs look. So these are, each circle's a region. So you have US East 1, 2, and 3, and US West 1, 2, and 3. And my geography's terrible, guys. Don't pick me up on that. But I know this is Australia, and we've got 3 availability zones. So this is a region. You need to understand the difference between regions and availability zones. There's lots of questions about that. And these are availability zones, regions and availability zones. Availability zones are separate data centers that are physically separate but close with high-speed links in between them. I think this is 2 Sydney and 1 Melbourne. I think this is how this works. But they don't actually tell you, and you don't actually know. When you deploy your instance, you can pick an availability, you pick a region and an availability zone. Like you'll say, I want region 2 in Sydney. You want region 2 in Australia here, but you can't say Sydney. And they randomise what the availability zones mean, so you don't actually know if it's sitting in Melbourne or Sydney. And you have to do some detective work yourself if you want to work out if it's Melbourne or Sydney. Because it shouldn't matter to you, right? You want to have your application in 2 availability zones. It doesn't matter which one's Sydney, which one's Melbourne.
So is that all users are using those centers? Are there going to be more? They must be enormous.
Yeah, they build them, they add to them all the time. So this is a map at a point in time. It's probably outdated. But so this is how many data centers Amazon's got at least. So we've got, like I said, 3 in Australia. If you're deploying an application and most of your users are in Australia, you should deploy it in Australia. If most of your users are global, you should deploy your application probably in the US. You can deploy it. So you've got, say, an instance running in the US, in Europe and Australia. And when the user clicks, it goes to the closest one. So that's another way you can deploy it. And you can have region failover. So if the Australian region totally falls over, it fails over and goes on to the US region. It depends how you design it. And depends how much money the client's got and things like that. But remember, a lot of these resources, you're charging per minute for what you do use. So sometimes it doesn't cost you any more to have a dual availability zone or dual region, because you're going to have 2 servers running anyway for how much resources you needed. Why not have one in the US and one in Australia? It costs you the same amount. Everything's cheaper in the US by about 25%, and data's cheaper by about 50%, I think, in the US. So things are a bit cheaper if you pick instances in the US. But if you've got a lot of Australian users, you should have them in Australia. You've got legal issues as well. Depends if your client's got, if they're banking or finance or lawyers, and you deploy it in the US, then you've got a US jurisdiction issues. You might not want the FBI poking around in your data. So that might be another reason you might want to deploy it in Sydney.
Wow.
So, how are we going for time? Yeah, we're getting there. AWS Marketplace. Here's something a lot of people aren't aware of. I'll let you go and have a look at that later. But there's a lot of third-party applications. And when I say a lot, I haven't looked recently, but thousands. And it's all the popular software you might ever think of. You just think of the name of the software, it'll be in the marketplace. And not only, and when you deploy these, you not only rent the software, it'll be licensed and configured for you, and it includes the EC2 instance. So you just go, I want a copy of some reporting software or something, click on it, and boom, install it and run it. You don't have to go and sign up the license. You don't have to pay for the license, and you're paying for everything by the minute. The software, the EC2 instance, and it's all configured and going for you. So some of these are really quick to get going, and it's a really good option. It's obviously not a good option if you already own the licenses. Obviously, you don't want to do this, but it's if you only want to run it for a couple of days or a week, it's awesome just to pay for the license for a week and then turn it off when you don't want to use it again. So the AWS Marketplace is an important thing to understand. There's questions about it, not in my quiz, but there's definitely questions about that one. This is a sort of thing that you'll hear lots of people talk about. And this is why I put this slide in here, because a lot of people will say, oh, AWS is too expensive. I've had a look, I compared getting an instance, getting a VPS and comparing an EC2. The EC2 instance is about 3 times the cost or 5 times the cost. Why would you use Amazon? And if you compare a very simple one discrete thing like an EC2 instance versus VPS, Amazon will come out as overly complicated and complex. It's harder to deploy, you've got to learn a lot more, and it will come out as overpriced. And I guarantee that's what people will say to you. But what you're really doing, we're looking for corporate solutions for corporates. So if you're only ever going to have one little website, you're better off going somewhere else and getting a VPS because it's cheaper and easier. But if you've got a corporate and your scale and your thinking and your long-term solutions beyond one little instance, and you're buying into the whole AWS environment where you might want distributed across regions and you might want to auto scale and you want elastic and no single point of failure, then buying your EC2, buying your instance or your VPS off someone that can't do all that, it doesn't make sense anymore. You need to consider they're getting best practice at each step. Amazon's considered best practice in almost every area. We'll look at RDSs later. That's a relational database instance. So this is just a good example that not only you get the instance, but you get the software. It's run by Amazon. It's tuned, and they do the database administration. So it's instead of hiring a database administrator. So if you just compared that on a complexity scale or on a cost scale, it doesn't show up all the other benefits that you're getting. I think infrastructure software is a really big part of what makes a difference longer term to corporates. And for example, if you compared a single VPS, a single VM, to an auto-scaling web platform, Amazon kills it. You've got a lot more flexibility. You've got the elasticity, and the elasticity actually can save you money. So if you're having a single VM environment comparison, they'd have to run one big VM, maybe with 16 cores for a larger web application I'm talking about, or 32 cores. You have to pay for that all the time. But under AWS, you might have an auto-scaling platform that auto-scales units out of 2 cores or 4 cores and runs how many you need. So overnight, it contracts them down, and during your busy period, it might run up 100 or 200 cores. So then it matches what your customers need, and then it drops it down. So you can save money by auto-scaling, which is very difficult to do in other environments. How are we going with questions, Guy, there?
Oh, we have many. So I can just keep going through the rest of your content, and then we'll have
my next couple of slides are extensions, and I'm pretty happy to take some questions. And
sure. As you know, and as many of you listening along who have been here before will know, I'm not particularly technical. So if you maybe open up the Q&A, that we've got rid of as many as we can, but then there's a fair few in there that you can...
Oh, you want me to open up the Q&A?
Yeah, if you look at the, because otherwise I'll just ask questions that
Okay, I'm
really
just clicking on
really
it.
shouldn't be asked. Um, two steps removed from a Luddite.
Oh, that's okay. No, I've got. It came up. I just didn't see where it came up. Okay. Let me just have a look at some questions. Raghav asks, is there any guidelines for selecting instances and how to evaluate clients' requirements for instance selection? It's an important question. I guess part of it comes down to experience. I think sometimes if you're coming from an existing environment where you've got a database server running or the application already running, and you know how much memory it's using and how many cores it's using. So sometimes the client can tell you it's using 4 cores and 8 gigs of RAM, and you can go and look that up on the matrix of the instance type. Well, that's easy. Sometimes it's easy. They give it to you. And remember, start off with the general ones and look at the compute and memory ones and stay away from the exotic ones because you'll just trip yourself up. Stay away from the T instances. Failing that, you know, a bit of experience, or start small and then increase it as they need. You'll get a feel for it. If it's an exam question, there's usually some hints as to what you should be looking for as well. Can you move from a reserved instance to an on-demand instance midway, say after 1 year? So Krisha asked this. So reserved instances is a whole complicated topic in itself, but suffice to say, when you purchase a reserve instance, it's not mapping one-to-one against a particular instance. What it does is at the end of the month, AWS work out all your on-demand hours, and then they remove any reserve instance hours that you've bought. So hey, say you had 1,200 on-demand hours and you had 700 reserved hours you paid for. They just take that off and go, all right, you've got 500 hours to pay for on-demand, plus we'll charge you your reserved instance price. So some sort of calculation like that. I hope that answers the question. Difference between a dedicated host and a dedicated instance. It's complicated. I'll leave that up to people to read up about that. But a dedicated host, you can run many instances on that, but you're guaranteed you're the only one on there. And the idea for that might be for security, or you might be a banking customer, or you might have some sort of corporate mandate, things like that. So the dedicated bits and pieces, you should definitely never use them. They're never going to be the answer to anything. You're never going to tell them to a client to use them. The customer will come and tell you, we've got a corporate mandate. We must use dedicated instances or dedicated hosts. They'll come and tell you. So it will be pretty clear. Can I run a Hyper-V server? No. You can't run Hyper-V or VMware inside an instance in EC2. It doesn't work. So there's someone asked that. Is CloudWatch monitoring included in the instance pricing itself? Complicated question and complicated answer. You get some CloudWatch for free. Good question. And you get the high level hypervisor statistics for free. So before, I'll go back and put my screen back for you. So anything that can be grabbed from the hypervisor is free. So for example, this is all free. Network packets, disk read, CPU utilization, this is all free. If you click on CloudWatch monitoring, enable detail monitoring, you get more monitoring, it's more often, and you can get some inside VM monitoring, and that there's a cost for that. So the answer is yes and no to that question. Hope that sort of answers that question. If we select a G type, so Santosh asks, if we select the G type and demand comes up from customers for more memory, can we switch to the R type? Yep. So you can change anytime. Stop the instance, connect the volume to a new instance, and it can be between types and start it again. I'll come down to some later questions as well.
Yeah, as is often the case, as soon as we open the questions, just dozens of excellent questions pour in.
Yeah, Phil asks, if you've used the AWS console to provision an EC2 instance, does the CLI describe instance give you all the information you need to programmatically recreate the environment? Yes, it does, Phil. There's a few other ways to do that as well. There's some products from AWS to capture your application deployment, which might be across instances and databases and volumes. And you can encapsulate that and store that as a JSON object. And then you can deploy that JSON object later. I'm sort of trying to do a run around what you're asking the question. So there's Amazon products to do that. So you can template a lot of these things. How do we know about any legal issues to define resources across various regions? Upendra asks. Well, you've got to be a bit of a legal genius. But again, your client might tell you these sorts of things. So if your client is a US-based company and they ask you to deploy an EC2 instance, obviously deploy it in the US. So they've got the same jurisdiction. Same as if you've got a Sydney client, deploy that in Sydney. So then you don't have to think about the cross jurisdiction. If they're a global company, they'll have a legal department and they'll give you some ideas where they want their data deployed in. So Matt asks, what are the use cases for AWS over Azure or Alibaba? I'd say Alibaba are cheaper and do a similar job. But I think AWS are more mature. So I think if anyone's going to recommend Alibaba over AWS, you're sort of going to put your job on the line to save the client some money. And I'll tell you, I wouldn't want to be that guy. Azure, now that's the Microsoft version of Amazon. If you're predominantly Microsoft house or completely a Microsoft house, I would consider Azure over AWS. Again, I think AWS is more mature, but a lot of the things are similar. So let me have a look at some other questions. Payal's got a question about licensing. Is it good to use BYOD licensing or Amazon offered licensing? I think the answer depends. If you've already got the BYOD, use that. I like the Amazon licensing because it's quick and easy and you pay by the minute and you don't have to think about it. So I like to use Amazon the way it should be used, and I just think it reduces headaches if you just use Amazon pay by the minute licensing. It's great. I love it. Anonymous asks, is buying or renting apps from Marketplace akin to using SaaS, software as a service, while AWS is traditionally IaaS, infrastructure as a service? Yep, I think that's an accurate way of looking at it, or platform as a service, or infrastructure as a service, either way. So yes, I think that's a good way of looking at it. Rasika asks, in case of my EC2 instance is not responding and needs a forceful restart, how can I achieve that? Right click, instance state, reboot. So that'll do a hard reset on the instance. And that's a good question. That's a common thing you need to do. And that's why I put that alarm. You saw that alarm I did before? You can just automate that. So that's a bit easier. Can you run Docker containers in an instance? So you can pretty much do anything in an instance you want other than run virtualization software. So, but you can run Docker inside an instance because it's not sort of considered virtualization for some reason. Amazon have got their own ways of running Docker containers if you want. For example, so there's a couple of different ways they run Docker, but you can run it on your own instance as well. And the same thing with databases. You can use their database, Amazon's database instances, or you can just start up your own instance and just run your database yourself. It really depends, who do you want to manage it? Do you want AWS to manage your Docker instances for you and scaling them and security? or do you want to manage them yourself and managing scale and security yourself? So again, it comes back to, I think you should use AWS the way it's meant to be used. And if AWS offers a Docker service, you should probably use that. Fard asks, is there a replicating cost when moving data in different AZ's regions? Yes. So Amazon charge you for everything. And that's sort of what annoys people sometimes, but I guess that's fair. So you get charged for internet data. There's one charge for that. That's the highest data charge. If you replicate within an availability zone within a VPC, it's free. But if you go between AZs, there is a small cost. It's about 10% of the normal data charge. So it's about 90% discounted. So it's heavily discounted and it's very fast. But there is a cost. So
maybe just one or two more questions, because we just keep getting more as you answer them. So as usual, folks, thanks for sending in the questions. They're all, fantastic. A great idea is if we don't get to it during a webinar, chuck it in the forums. There's thousands of people who might be able to answer the question. You can maybe have a really interesting chat about things.
Okay, I've got a good one from Jimmy though. If instances are ephemeral, which remember we said are disposable, how can you have certainty that your application will always be available? So that's a good point. So if part of your design is the instance might be destroyed at any time, how are we going to make our application reliable? So later in the course, we'll look at load balancing, auto scaling groups, and target groups. So the idea is you have a fleet of machines in EC2 instances running your web application. And they might scale from 1 to 20 or 1 to 50 application instances, depending on how many you need. So if one fails in a fleet and it's auto scaling, one gets taken out of the roster and EC2 put a new one in there. And so it doesn't really matter that one failed because you had 4 anyway. One goes down, and to get the capacity back up, you start another 1 or 2. So it's the design that makes it get past the fact that it's ephemeral. I think I like these questions. I think they show a lot of thinking, guys, so it's pretty good.
Great.
Faraz has got a good question. Do EC2 instances only run Amazon machine images, or can they run, I think it means can they run other images as well? So you can choose to run Amazon Linux, you can choose to run Ubuntu, you can choose anything from the marketplace. So some things from the marketplace are free. For example, Ubuntu puts their distributions daily into the marketplace and they're free to run. Red Hat put them in there, and there's free and paid Red Hat ones as well. And same thing with Windows. When Microsoft put their ones in there, and obviously you've got to charge on top of it for the license fee. So you can choose what distributions and operating systems and applications you want. Randall's got a question. How does horizontal scaling work at the file storage level? If I've got 1,000 compute nodes serving my website, does that melt the file store? So that's a good question. So more often than not, a website will be served from a database, not always, but from a database. So you separate the web application and the compute nodes from the database, and you scale the database separately, which is a whole another question. And so you still might have, for example, PHP code sitting on your local file store, which is the application. And how do you scale that? So Amazon got a few different ways of doing that. And one of the ways is a thing called EFS, which is like a NAS share or an NFS share. And they call it the elastic file system. So there's usually, if there's a problem or something to scaling, Amazon's usually thought of it, and there's usually a product to fit it. You can find which one it is. And we've got a whole subject on storage next week or something. I think next week's storage. So we'll talk about it then more. I'm pretty happy with you, Guy. How are you going there?
Yeah, all good. Yeah, if you want to get to those extension slides,
Okay.
that'll be nice too. And
So
yeah,
my extension slides is the thinking above the certifications, and it's the postgraduate work that sort of leads into the assessments. And I think infrastructure as software is a very important component for large corporates. So when you build a virtual machine in a corporate environment, a lot of work goes into building that and maintaining it and keeping the operating system up to date, keeping the software up to date, lots of settings in the software. And then if you have to redeploy that for test or development or staging, it's very difficult to duplicate it sometimes. Or if it was lost, it's very difficult to rebuild it. And of course you have backups, but sometimes backups don't work either because you've had too many changes or something. It's hard to go back. But the idea of using infrastructure software, you put all your build and deploy instructions as part of your application, and it gets managed like source code does. So when you go from test to staging to production, all your deployment instructions for launching EC2 instances, what software to run on there, how to configure that is all part of the software. And it gets managed in a more controlled and organized manner. So I think that's a very big part that corporates, it's very valuable to corporates to pull all the assets out of sitting in virtual machines and put them in and manage them as software. Oh, that was my last extension slide. I thought I had another one.
Okay, no, you've already given us a lot of extra time, so thank you so much. Given it's 20 past, we might not go for more questions. But next week, I believe we're talking about storage. Is that the plan?
I don't have next week's schedule, but I think it is.
Okay, beauty. So yeah, we'll be talking about storage next week. Just from the course overview, we've got differences between various storage types, performance and scalability, programmability, security, and use cases. Thanks heaps for all your questions. Again, if we didn't get to your question, please just chuck it in the forum because it'll no doubt spark a really interesting conversation. There'll be hundreds of posts in there in the course of the next few weeks.
I'll have a look through the forum questions and put some, my comments here and there.
Fantastic.
Can't answer them all, but I'll have a look at some.
Beauty.
Thanks. I already answered someone's question about artificial intelligence and machine language during the week.
Oh, good.
That's something I think is pretty cool.
Okay, great. Well, I guess just thanks to Barry and Chantel and Angus for hanging around and looking after the chat and the questions. Thanks a lot, Scott, for this week. I'll let you sign off and then maybe end the meeting when you're ready to go.
Okay, thanks, Guy.